Okie dokie. Hello, I'm Professor David, and let's figure out how vector value functions work. So, maybe I should move this like so, how do vector valued functions work? Well, basically, let's say we have a point, right? And you should be able to, you played Minecraft before, so let's say it's like 7, 8, 22, right? Let's say, yeah, let's just say that's what a point is. Let's say a point, let's not do vector, but the vector for this would be, you need another point to make the vector, but let's just say this vector is the same exact, right? So that's a point on this vector basically, and a vector is basically like the direction, it's pointing in a direction. So it's less, it's more of like a vibe, like it's, like, it's so weird, calculus gets so weird, but like basically a vector is more of a vibe-based thing rather than like a point. Like a point is a point right there, but a vector is more like, oh, this is the vibe of where it's headed-ish. Like you can plot it, you know, but it'll be like this, and it's kind of like, it's not really a line, but it's kind of like the vector's headed somewhere. Anyway, so we get to the question of what is a vector value function? Well, a vector value function, it's r in terms of t. So how does that work, right? So how are you in terms of t when you only have 3 variables, you know? You have your x, your y, and your z, right? And so how does that work? Well, it turns out that all of these are independent of one another. However, x, y, and z are all dependent on t. And let's just say t is time, because that makes it easier to understand the concept of what a vector value function is. So t is our time, right? And let's say these are position. So we have x, y, and z as the position of where it could be, and then we have t as time. So I think the method that we learned in class was a bug crawling around. So let's say you have a bug, and let's call him Timmy, right? And so Timmy, this is Timmy. And so let's say Timmy is at 0 to 3, right? And let's say the time is 1:30, right? PM. Let's do PM. So then let's say Timmy decides to go walk over here, and now he's here. And let's say he's at, this is like not, it's a graph, this is horrible, but this is on what, the x-axis right now. And let's say we're in a 3D plane because we're using 3 points, but even it's a lot easier to see if you're on a 2D plane. But let's say for the sake of this, we're on a 3D plane, just to make it, I think it's like that. That's easy. And let's say that Timmy ends up at like 2, 4, 5, right? And then let's say t is equal to 140 now. So because we moved here, the time it takes Timmy, and this is kind of like the weirdness of calculus when you get here, it kind of becomes more concept and like application rather than like just like applying shit, because like a lot of time you don't do like really good word problems, like unless you're in like pre-calculus stuff. And so let's say Timmy moves here and he's there. Now the time is 140. So 10 minutes have passed in between these 2 times. And because it takes Timmy that amount of time to go there, all these values, x, y, and z, are dependent on t, which is time. So when you're writing these out, you basically write in this notation. I don't know if you're supposed to take physics, I don't think you have to, but it's basically, I think it's I hat, j hat, k hat. That's when you get into dot products or cross products and all that stuff. But these 3 are basically the notation for this. So when you enter it into this formula right here, you would put, like, let's say sine theta close I hat plus cosine theta j hat plus, let's just do k hat, right? And so now that you have that, that's like something, and really what you start to understand what like all of these, you start to understand what these are for. You understand what sine and cosine are for now, and you start to understand like, oh wait, that makes sense now, you know. And so you understand like, oh, sine, if you graph it, especially in Calc3, you're able to see like, oh, sine is just like, it's basically everything. Math becomes command systems, if that makes any sense. And it's less. It really it just becomes commands. So you understand like sine and cosine are all trig functions for the most part are gonna have oscillations. So it's like the frequencies, you know, and like it becomes like then you have like your wavelengths and stuff. Crest to crest, trough to trough, and it's like you start to get these things, and you're like, oh, you plug in these to this in order to get a result from them. So when you're doing like your baby graphs and stuff on your 2D, that's most plain, simple like y and x. Ooh, that's the first one. And then you're like, oh, I'm graphing this, right? But then, let's say now you're in the 3D plane, and now you can start to do more complex things. So let's say I want to make a circle. I think this is borderline a circle. Let's say I want to make a circle now. And so now you can make a circle, but that circle can have like an oscillation to it, and you can start to get more complex with imaging systems. So like that's how you scan brains and all that shit. And so you get to like this weird like, so like yeah, you can graph a circle, but now your circle can go up like that. And it could get larger, it could get smaller, and then let's say you can graph it on an axis, and you can say, hey, that's going through z, right? And that's on the z-axis, and then you have your x and y, you know. But it's like, oh, that's on a whole different axis now that you're just going up, and then you can play it, and maybe that's a force, and that's like now you're pushing it up to a certain speed, and there's just like so many things that you can start to do with these systems that is just like so funky, and you're like, oh, this is what math is for. Imaging systems, you know, data, like understanding hard systems. Like I think one of them was like meteorology, all these systems that you were able to like finally image and realize through complex systems like calculus. You know, it's really just like, it's a way to like measure the world, you know. That's why physics is like based, it's calculus 3 based science, because you need it. Because it's like chaos and all these things are like tangible things that you can look at and understand when you just put a little math to it. Anyway. Yeah.